Hey guys, and welcome back to the shop. In part one of the Yaesu FT77, we looked over this radio and we diagnosed several problems with it. One was the VFO that we have now corrected. I still have to figure out what I'm going to do about the knob situation. I'm definitely going to make it. I just don't know if I'm going to make it a one piece or a two piece yet, so I'll be working on that. We also found out that, the receiver was down. There was several controls that was dirty, and we also found out that there's been some shoddy work going on in the PA compartment. We did determine that it was a 100 watt PA, not the 10 watt PA, and I understand that the FT77 came out with a S version, and that was the 10 watt version of this radio. So what I want to do on this video is tear into that PA unit and see if we can figure out just what's going on in it. So the good thing is we should be able to disconnect this whole board and bring it outside of its heat sink. There's only a few connections. We have the RF input, RF output. There's a ground wire, 13.8 wire, and 13.8 transmit wire. So we should be able to disconnect these three just by unplugging them. But these, the center and ground of the coax, will have to be unsoldered from the pins on the board. So I'm gonna go ahead and get that done and get this unit out, and we'll have a look at it. And guys, really it was that easy. Just unbolted the whole heat sink from the back cover of the radio. Was able to pull it out a little further because it doesn't have all that wiring for the accessory jacks and stuff connected to that, and disconnected the wires, and then removed all the screws out of the board and around the edges, and took the PA right off the board. And I started just going through and sweeping across and looking for issues in this thing, and I have found a few. Now right over here off the transmit 13.8 volt rail, there is a tantalum capacitor on that rail that is fried, and it is right there, right at the tip of it. You see that black blob? That is actually supposed to be a orange tantalum capacitor. So I went ahead and grabbed the microscope, and you can see this orange tantalum capacitor here is completely burnt black on the top of it. And you can see here's the leg, and it's supposed to connect here, and it looks like somebody has clipped it out of circuit. And that capacitor, I think it's a 4.7 microfarad. It just connects to the 13.8 volt transmit rail down to ground. So sweeping on over here, I'm checking everything, and I come across this resistor capacitor combination is not even soldered to this side of that transformer coil. And there you can see the end of it here. It's supposed to be soldered here to this blob on the coil, and that's not even been soldered. So the other one is this silver dip capacitor that's here. It's supposed to be soldered down on the end of this binocular transformer, and you can see there's the wire, and it has been unsoldered. So I did notice there's a screw right here that goes into the top and into the heatsink, and that has to be removed. If this capacitor was there, you wouldn't be able to move. So it looks like somebody attempted to remove this before and just maybe did not finish it up and gave up on it for some reason. So as we look through the schematic here, we can see the 13.8 volt transmit line comes up, and it goes into the input of Q6. And if you look right over here, there is that tantalum capacitor that's supposed to be from the end to ground. Looking over on the input side of the binocular transformer for the finals, we can see a capacitor resistor in this area that is connected to each winding, the secondary windings of that TO2, I believe it is. Can't hardly read it, but I think it's TO2. So one end of that's been disconnected. And on the output side, we have one of these capacitors. You see there's two of them here. One of these capacitors has been disconnected, probably to get that screw out that's underneath of it, so maybe that's okay. So we have a 2SC1589, that is the buffer transistor that goes into the drivers, and the drivers are 2SC2395s. This goes through our first transformer and comes out and feeds the 2SC2290s, where the large amount of amplification is done. And actually what I want to do now is go ahead and repair the faults and then connect this back up to the radio with some extension cables so we can keep this outside the radio. I will mount this back on the heat sink, and that way we can go through and check for voltages, check this bias circuit, see if it's biasing the final transistors like it's supposed to, and see if we can find out the trouble with this thing. Alright guys, I got the amplifier connected back in, and I got it hooked up to the IFR. I went ahead and turned the bias control part all the way down because I just wanted to check out the signal flowing through the amplifier. And we're going to do this by using our scope. And what I'll do is come over here and start scoping at the input and work our way through the section. So the first thing we could do is look at the power coming out of the radio itself. So I'll connect this up to ground and to the semiconductor, the coax. I've got the Rigol set up. To read this, radio's on, we in CW, and there's our input signal. And if you look, it's showing about 140 microvolts. Now, you know, I can turn this on up to where I want it, and we can see that signal coming into the amplifier. So that is going to be the signal that is feeding the buffer transistor here. So we can go to this transistor and look at the output of it and see if that transistor is working. So we saw the signal coming into the transistor, so we look at the signal coming out of the transistor. We're seeing about 700 microvolts coming out. So that transistor is turning on and working. Right now we're going to go to our drivers and look at the output at the transformer and see exactly what we have. And since this is divided, we'll be looking at each transistor. Okay, so here's one transistor. We're showing about 1.2 volts. And on the other transistor, we're showing about 980 to 1 volt. So our driver transistors are working. Okay, so what we want to do now is look at the outputs and see if we have any signal coming out of each one of the two SE2290s. And we'll just scope each one of them and see. So here's the first one, 120 millivolts, and the second one, about 100 millivolts. So we'll combine both of them and look at it. And that's about 80 to 100 millivolts. Okay, so we'll look at the current draw. We've got our 13.8 volts feeding the circuit. We're going to come here and disconnect that wire that's feeding the output transistors, and we're going to put a meter across it. Okay, I got the meter connected up. We're going to key the radio. And it looks like about 60 milliamps. We'll key the radio back up. We're going to turn up the bias voltage. And as you see, it makes no difference at all. Alright, I want to look to see if our bias voltage is adjusting. You can see there's a VR right here. But we're going to look at the output of Q7, where it comes up to the center tap on the output of the driver transistors. You can see our core here. And then we can see where our core goes for our other transistor. Okay. Got that connected up. I'm going to key the transmitter. And the bias control is all the way down. It's 0.649 volts. And when I turn this, it should come up. And you can see it come all the way up to 1.03 volts. And back down to 0.65. So our bias circuit is working. So guys, what my conclusion is that those two SE2290s are no good. They are both dead. I'm going to look around here in the shop and see if I can find some and get these things replaced. Well guys, after about 30 minutes of digging deep, I did find a unused pair of two SE2290s. These are Toshibas. So we'll get these checked out and we'll get them installed and see what happens. Well guys, you can see I got the old transistors out, and they physically look in bad shape. that's caused from excessive heat. So something really going on there. It got so hot that it released the adhesive just holding the ceramic tops on. So I got one of them under the microscope, and you can see the bonding wires that attach to the die are completely blown out. There's none over here. You can see how these are just all blackened, and you can see inside the die the bonding wires in the die are just blowed out of proportion. Now here's the other one. You can see the bonding wires here don't look too bad, but you can see on the die itself they're just blowed out. So what I got to do now is go ahead and clean up this circuit board and get all this, massive amount of solder in there, just way too much. So I'll go ahead and get all that cleaned out, and we'll test these resistors, make sure all that's fine. There's a couple of resistors on each side we'll need to test, just to make sure everything is in shape, because them transistors look like they had a hard life, and I like to investigate, make sure everything around is doing okay. Okay guys, I got the PA rebuilt. I got the 2 new final transistors in. The tantalum capacitor replaced. That was bad. Got all the soldered joints all fixed up, making better connection now. And what I'm going to do, I'm going to power the amplifier from the HP 8656B signal generator. And at the whole time I'm going to do this, I'm going to be looking at our voltage on our bias for the transistors. I'll be looking at the scope, and I'll be looking at the watt meter. So all this is going to happen real quick. So basically what I've done on the RF is that I removed the center conductor, and I'll have our signal generator connected here. Now you got to remember, this PA doesn't take but about a watt of power to activate the chain, and I can control it a little better since this doesn't have this radio doesn't have a real RF drive control. So I can put minimum voltage on the input to drive the chains, and I'll look at it all at the same time. Okay, so I got all 3 instruments where I can see them all at one time. Okay, I'm going to feed about 3 microvolts from the generator into the PA. We'll key the transmitter in CW mode, and then I'll turn the RF output on. And we should see about, with the way I got it, with about 3 microvolts, we should get, if the PA is working correctly and the bias is not all screwed up, we should see about 70 to 80 watts on the watt meter. I'm looking at about 0.6 to 0.7 volts on the bias, and we should see all waveform. So we'll go ahead and we'll key the transmitter, turn the signal generator on. I'm showing 80 watts, 0.6 volts, and we can see our waveform. And that's just a quick test of the power amplifier. Now we know that it's working. Okay, by that test we know that our power amplifier is working, and we know that our LPF unit is working. Because the power comes out of the PA and into the LPF unit, and then out to the antenna port, so that we know that that part's good. Okay, so now I got our RF input cable from the rig connected back to the PA, and we want to test and see just what we get now. Okay, that's hooked up, radio's on. All we got to do is key the transmitter. And we're seeing our bias voltage, but we have no output and very, very little waveform. The scope is detecting it, but the watt meter is only registering less than a watt of power. So it looks like we have a another additional problem in the transmit settler, and this time it is coming from the RF unit. So we're going to have to get in there and troubleshoot that RF unit. So here, looking at the main schematic, you can see here on the RF unit, transmit RF out, and that goes right up and goes to RF input of the PA unit. So we got something in this unit here that is not working correctly. Okay guys, well the PA unit seems to be working fine now. Just got to get the bias and stuff set right on it. But you know, I'm sitting here thinking of everything I saw inside this PA unit lead me to believe that the technician that worked on it before did not troubleshoot far enough to find out what the real problem was. One of the dead giveaways on this was where you saw all the stuff that was disconnecting the bad solder joints and stuff. But what really gave away was the bias control part was cranked wide open, and that in turn fried the finals to the point of separating. So you know, the issue probably was in the RF unit to start with, and they thought it was in the PA unit, wasn't producing power right. So they went to the next to the last stage and started there. And you know, we all make those mistakes from time to time, but you know, that's the way things happen. But anyway, I'm going to call this part 2, and in part 3 we'll go to our RF unit and see what we can find. Okay, so before we start troubleshooting the PA unit, the one thing I want to do is look at the RF input coming out of the RF unit to see if it has a healthy signal there. We already know there's problems in the PA, but we want to look at what is driving that PA and see how it's working. So I got the scope attached to the RF input leads, and we're going to come up here and look at it on the scope. And we'll key the transmitter up, and we do have a signal. But if you notice, that's about 10.6 microvolts. So we're not even getting a healthy signal to even drive the PA, and this this tells me that why the PA is in the shape that it is. The technician went to the wrong place to find the issue, and in turn just about destroyed the PA unit. So we don't even have a good signal going to the PA. And you know, that happens if you're not very familiar with how this works. You know, you got your RF board, you got a band switch, mixers, filters that it goes through, then it comes to the PA, and then from the PA it doesn't go out the antenna, it goes to the LPF unit through the directional coupler and then out the antenna port. And it can be a little confusing for those that are not used to working on such things. So how this amplifier works is providing that we have a good signal coming in. We can see our signal comes in straight to the pre-driver, which is a 2SC1589. Then goes through the first transformer, TO1, and is divided out into the driver transistors, which are 2SC3395. Goes through T2, which is our second transformer, and it's divided out and goes to our 2SC2290s. Then it goes to the last transformer and out the PA jack. And on transmit voltage, the transmit voltage comes up and feeds a 7808 voltage regulator, and this in turn feeds a 2SD235, which is adjustable, and that sends our bias voltage up to T2 to bias the final transistors. So guys, since the PA is working like it's supposed to, and if you noticed, I got the bias cut way down because I didn't want to set the bias using the signal generator. It needs to be done using the radio itself. And you can see here, this is the output connection that goes to the PA to drive the PA. Once this RF board is repaired, then we can set the bias on the final amplifier. We also got a couple other little issues. This coupling connector here is all cracked up, and the band switch will slip. One good thing is that it does have a stop, but you can still keep turning it, and what it is, this shaft is sliding inside this connector due to these cracks around these screws. So we're going to have to get on the lathe and make a new metal coupler to go on this, and that should take care of that problem. And I want to thank you guys for the opportunity to get to repair stuff like this, because if it weren't for you guys, this radio probably could have been parted out, scrapped, or whatever. And the reason why I'm thanking you guys is if it weren't for you, I wouldn't do these videos to save these old radios. So in part 3, we'll tackle this RF board and go through it and fix this connector and this coupler and get, you know, everything straightened out in the RF unit. And then we'll move on to checking the radio out real good, see if there's any other issues that we see, and then we'll make another video. We'll go ahead and recap this thing and get this thing back on the air like it used to be when it was first produced. So guys, that's it with part 2. We'll see you in part 3 sometime in the near future. And if we don't get to get another video out this year, I want to say hope everybody has a Merry Christmas and a Happy New Year, and we'll see you in the next video. Bye now.